Hi everyone, in this video I'm going to explain the concepts of magnetic circuits and some basic definitions in the magnetic field. First of all, what is meant by magnetic field? It is a region around a permanent magnet in which there is a force created by the movement of electric charges. That means any permanent magnet can produce magnetic flux, and the region of the magnetic flux is called as magnetic field. The magnetic field exists around a coil carrying current, magnetic dipoles, and also changing the electric fields. The magnetic field is measured in the units of Tesla or Gauss. Tesla is measured in SI units, that is, SI units for magnetic field is in Tesla, and for CG system, the units for magnetic field is Gauss. Next, magnetic flux. Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface is called as magnetic flux. These flux lines are imaginary lines around the magnet. That means the flux lines are not visible to the human eye. That's why those are called as imaginary lines. It gives the measurement of total magnetic field that passes through a given surface. Magnetic flux is usually measured with a meter called as flux meter. So it is analogous to electric current in the electric circuit. That means in electric circuits, the current is called as a magnetic flux in the magnetic field. So magnetic flux can be designated with a sign phi, and its SI unit is Weber, and in CGS unit is Maxwell. So this is a current carrying conductor connected around the north and south pole here. So if you observe here, the flux lines are started at the north pole and in the form of a closed circuit and entering at the south pole. If you observe all the flux lines which are parallel to each other, which are not intersecting anyone, so the flux lines starts at a north point and reaches at the south point. So here on the both side of this north and south pole magnet, we have current carrying conductors are there. So this is the current carrying conductors which are represented with a cross mark. Here the current carrying conductors which are representing in the dot. So here for a cross mark, the current carrying conductors is a clockwise direction. For dot symbol, the currents which are flowing in the anti-clockwise direction. So if you see the properties of the magnetic flux, so they are always form a closed path. So they always starts from one north pole and ends at the south pole. So they never intersect each other. So magnetic lines of force that are parallel to each other and are in same direction repel each other. That means the magnetic flux lines which are in the same direction, these can repel each other, and in the opposite direction, so those can attract together, and some of the flux that get cancelled here there. So the magnetic flux passing through a surface, a vector A is given as phi is equal to B into A, where B is called as flux density, A is called as area of the magnetic flux that is established. So therefore phi is a dot product, so B dot A is equal to, we can write BA cos theta. So where theta is nothing but angle, perpendicular distance from the surface. So where the unit for flux is 1 Weber, so where 1 Weber is nothing but 10 lines of magnetic force. Next, flux density. So the flux density can be defined as the flux lines passing through area of a material. So that is the area here, it is unit area. So it is designated with a symbol B. Therefore, flux density B is equal to phi by A. Where we know the units for phi, it is Webers, and area is meter square. Therefore, its units are Weber per meter square. So this Weber per meter square is called as Tesla. Next, very important term, magnetomotive force, MMF. So in case of electric field, we have EMF. EMF stands for electromotive force. In that, electro stands for electrons, motive means motivation, force means the force. So the force which motivates the electrons is called as electromotive force. Similarly, in case of magnetomotive force, here magneto means magnetic flux, motive means nothing but motivation, so force. So therefore the force which motivates the magnetic flux is called as magnetomotive force in short. Therefore, the force behind the flow of flux or production of flux in the magnetic circuit is called as magnetomotive force. It determines the magnetic field strength. So, this is a property of the MMF is it determines the magnetic field strength. So, it is a product of the number of turns of the magnetizing coil and the current passing through it. Therefore, MMF can be given one of the formula N into I, where N is called as number of turns in the coil, I is the current passing through it. So MMF can also be defined as the force act on unit north pole placed on the magnetic field. Therefore, the magnetic field MMF can also be defined as a product of H into L, where H is called as magnetic field strength, L is called as length of the magnetic circuit. Therefore, the unit for MMF is, so if you observe the formula N into I, N stands for number of turns, I stands for amperes, that is the current unit amperes. Therefore, the unit for MMF is ampere turns. So the magnetic field strength, its symbol is H, so it is given as a strength or weakness of the magnetic field. The name itself indicating magnetic field strength, it gives the strength of the magnetic field. That means if the magnetic field is stronger or weaker magnetic field, so that can be defined by using this index called as magnetic field strength. It is defined as the force experienced by a unit north pole when placed at any point in the magnetic field. Therefore, mathematically H can be defined as ampere turns by length. So from the previous definition, MMF can be given as one of the definition, MMF is equal to H into L, where H is nothing but magnetic field strength. So from this, H is equal to MMF by L. Therefore, the units here ampere turns by length units is meters. Therefore, H is equal to N into I by L. So magnetic field strength can be denoted with letter H and measured in Newton per Weber or ampere ton per meter. So Newton per Weber, the unit comes from the definition of this magnetic field strength, as it is defined as a force experienced by unit north pole. So therefore, the unit for force is Newton, and here it is north pole means flux, therefore it is Weber. So Newton per Weber, or from this definition, so unit is ampere turn per meter. So more the value of H, more stronger is the magnetic field. As said previously, magnetic field strength, it gives the strength of the magnetic field. Therefore, if the index value is high, the magnetic field is stronger, else the magnetic field is weaker. This is also called as magnetic field intensity. The other name for magnetic field strength is magnetic field intensity. So next, permeability. So the flow of flux by the magnet is not only depends on the strength of the magnetic field, but also depends on the medium in which the magnet placed. Generally, the magnet is subjected to some medium, generally it is air. But instead of air, if any other material is placed, so then the magnetic field intensity that can be varied. So therefore, that variability can be defined with an index called as permeability. So it is the ability of the magnetic material forces through the flux through a given medium. That means ability of the magnetic force through that forces the flux through a given medium. That means it is how much the force that flux can generated in the presence of a medium, that is index measured by permeability. So it is two indexes again. One is absolute permeability, symbol is mu naught. Next one is relative permeability, mu r. So therefore mu is equal to mu naught into mu r, where mu naught is called as absolute permeability. So it is the ratio of magnetic flux density in a particular medium to the magnetic field strength producing that flux density is called as absolute permeability of that medium. Therefore, mu is equal to B by H. Therefore, B is equal to mu H. This is a very, very important relation. The relation between magnetic flux density and the magnetic field strength is B is equal to mu H. Therefore, the unit for mu is Henry per meter. So, therefore, here the permeability of a free space or medium that can be given with the symbol mu naught. So here naught symbol stands for the free space or air or vacuum. Therefore mu naught can be defined as B by H. So its value can be calculated as 4.10⁻⁻7 Henry per meter. Next, relative permeability. So this is designated with the symbol mu r. So therefore it is defined as a ratio of the flux density produced in a medium other than free space to the flux density produced in the free space under the influence of same magnetic field strength and under identical conditions. So under these two conditions, if you calculate the ratio of flux density in the medium as well as in the free space, then the ratio is called as mu r. That mu r is equal to b by b naught. Since these two are having the same unit, therefore mu r has no units. Therefore, for a free space or medium or air, so b becomes b naught. Therefore, mu r value is equal to 1. So we know that mu naught is equal to b by h, and also mu r is equal to b by b naught. Therefore, if you do the ratio mu by mu r, then we are getting this ratio b by b naught. So therefore, mu by mu r is equal to mu naught. Therefore, we are getting mu is equal to mu naught into mu r. That is a Henry per meter. This is a very important relation. Already we defined in the previous mu is equal to mu naught into mu r here. So the derivation for this is here mentioned here. So from the two expressions, mu naught is equal to b by h and mu r is equal to b by b naught. So we are deriving this mu is equal to mu naught into mu r, and the units for mu is Henry per meter. Next, reluctance. So in case of electric circuit, we have a term called resistance. So the function of resistance is to oppose the flow of current. Here also the term is reluctance. So it is similar to resistance in the electric circuit. So it also opposes the magnetic field in the magnetic flux in the magnetic field. Therefore, the opposition by the material to the flow of magnetic flux is called as reluctance. So the flow of current opposing by resistance, the flow of magnetic flux opposing by reluctance. Therefore, the reluctance is directly proportional to length of the magnetic circuit and inversely proportional to the area of cross section. Therefore, S proportional to L by A. So, if you remove the proportionality constant by mu, S is equal to L by mu A, where mu nothing but mu naught into mu r, that is defined earlier. So, it is measured in the units ampere per Webers. So, here we have this unit come from the other definition. So it is also defined as a ratio of mmf to the flux produced. So therefore, reluctance can also be defined with mmf by flux. Therefore, the unit for mmf is the formula for mmf is n into I by phi. Therefore, the unit for reluctance is, we have already know the units for Ni, that is ampere turns, by flux unit is Weber. Therefore, the unit of reluctance is ampere turn per Weber. So S is equal to Ni by phi, and also S is equal to, we can write mmf formula as not only N into I, it is also H into L. Therefore, H into L by B into A. From the magnetic flux density definition, phi is equal to Ba. Therefore, H into L by, so B value we know that mu into H into A, so H gets cancelled. Therefore, S is equal to L by mu A. So where mu is equal to mu naught into mu r into A. So this is a formula for reluctance formula. S is equal to L by mu A, that is mu naught into mu r into A. So this is another way to define the reluctance formula. Next, last one, permeance. So the reciprocal of reluctance is called as permeance. Therefore, it is given by permeance is equal to 1 by reluctance. That means we know the reluctance formula, S is equal to L by mu A. So from this, permeance will be mu A by L. And the unit for permeance is just opposite to reluctance, that is Weber per ampere. Thank you.